More than 5 decades have passed since humans last voyaged beyond low Earth orbit. Between 1969 and 1972, NASA's Apollo missions carried 12 astronauts to the lunar surface, with Apollo 17 marking the final chapter of that era in December 1972. It's now been more than 53 years since humans last set foot on the moon. At long last, NASA's Artemis program is reigniting that legacy. Named for Artemis, the twin sister of Apollo in Greek mythology, this new lunar initiative aims not merely to visit the moon briefly, but to establish a sustained human presence there, harnessing the moon's resources and using it as a proving ground for technologies needed to reach Mars. Artemis I, NASA's uncrewed test flight in late 2022, proved the core systems by sending the Orion spacecraft on a 25-day journey around the moon and back, traveling over 2.25 million kilometers and enduring the harsh realities of deep space. With that success in hand, Artemis II will be the program's first crewed mission. As early as April 1st, 4 astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialists Christina Koch and Jeremy Hansen, will launch for a high-stakes lunar flyby, testing and validating the hardware with human passengers. At the center of this mission are 2 engineering marvels, the Space Launch System rocket, or SLS, and the Orion spacecraft. The SLS is NASA's most powerful rocket to date, a towering 322-foot launch vehicle capable of generating 39 meganewtons of thrust at liftoff, about 15% more than Apollo's Saturn V. Its core stage is powered by 4 RS-25 engines, each producing 1.8 meganewtons of thrust and burning a combination of liquid hydrogen and liquid oxygen. Attached to either side are 2 solid rocket boosters, each delivering 14.6 meganewtons of thrust and providing the bulk of the power during the first 2 minutes of ascent. Above the core stage sits the interim cryogenic propulsion stage, which uses a single RL-10 engine, also fueled by liquid hydrogen and oxygen, delivering 110 kilonewtons of thrust to place the crew capsule on its trajectory toward the moon. Nestled atop the SLS is Orion, the spacecraft that will carry the crew. Orion is a capsule-shaped vehicle, reminiscent of Apollo, but vastly more advanced. With a crew module that provides about 9 cubic meters of habitable space, roughly the size of a small van, comfortable for 4 astronauts. It houses advanced digital flight controls, a glass cockpit interface derived from modern commercial airliners, onboard computers, and backup manual controls in case of emergency. It also contains the full life support system, managing air, water, temperature, and waste, along with storage space and personal accommodations. The engineers have also built a robust heat shield beneath the crew module, made from coat, an ablative material specially designed to absorb and carry away extreme heat. This heat shield protects Orion during the fiery reentry to Earth when the capsule plunges back through the atmosphere at tremendous speed. Under Orion is the European Service Module, built by the European Space Agency. The Service Module is the powerhouse of Orion. It has the spacecraft's main engine and 8 smaller thrusters, fuel tanks, and the 4 large solar arrays that generate electricity. It provides in-space propulsion and carries consumables such as water, oxygen, and nitrogen needed for life support. On top of the crew module is the Launch Abort Tower, a safety system designed to instantly pull the capsule and crew away from the rocket in case of a serious problem during launch or ascent. With the hardware set, let's walk through the Artemis II mission profile, a meticulously planned 10-day odyssey that begins at Kennedy Space Center's Launch Complex 39B in Florida. At liftoff, the SLS unleashes its 4 main engines and twin solid boosters, propelling Orion, carrying the 4 Artemis II crew members inside, skyward with brute force. Within 2 minutes, the solid boosters separate, and about 6 minutes later, the core stage burns out and detaches, leaving the upper stage to propel and circularize Orion into an initial low Earth orbit, the first step on its journey to the moon. Once in orbit, Orion will separate from the upper stage, and the crew will check out Orion's systems, such as verifying life support functioning and communications systems, to ensure all is nominal before departing for the moon. After about 2 days in Earth orbit, Orion's European Service Module will ignite its main engine one final time to perform a translunar injection burn. This firing will place Orion on its course toward the moon. This mission uses a free return trajectory, a built-in safety path that uses the moon's gravity to swing Orion back toward Earth without requiring a major engine burn. So, even if a propulsion issue occurred mid-journey, the spacecraft would naturally return home along this curved path around the moon. Once on the translunar course, Orion will be coasting for about 4 days toward the moon. As it approaches, its path won't take it into low lunar orbit like past missions, but instead on a much more distant trajectory. For comparison, NASA's Lunar Reconnaissance Orbiter circles the moon at an altitude of about 50 kilometers, mapping the surface in fine detail. The Apollo missions traveled higher, orbiting at roughly 110 kilometers above the moon before their landing attempts. Artemis II goes far beyond both. During its flyby, Orion will pass the lunar far side at an altitude of around 8,000 kilometers. From that distant vantage point, the moon will still fill much of the view, while Earth, nearly 370,000 kilometers away, will appear as a small blue dot. At that moment, the Artemis II crew will be farther from Earth than any humans in history. As Orion loops around the moon, it will pass over the far side, a rugged, cratered landscape never visible from Earth, giving astronauts a chance to observe and photograph features like ancient impact basins and the dark volcanic plains known as Lunar Maria, formed when lava flooded those basins billions of years ago. Though the lunar flyby lasts only a few hours, it's the dramatic high point of the mission. Once past the moon, Orion will use gravity to slingshot itself back toward Earth on the free return trajectory. The return trip takes another 4 days, during which the crew will monitor spacecraft systems, conduct radiation and microgravity experiments, and prepare for reentry. Around day 9 or so, Orion will begin positioning for its final descent through Earth's atmosphere. Before entering the atmosphere, the crew module will separate from its European service module, jettisoning the propulsion stage that guided it through deep space, and then use onboard thrusters to orient the heat shield for reentry. As Orion nears Earth, it will be barreling in at nearly 11 kilometers per second, fast enough to generate extreme heating during atmospheric reentry. To manage the forces and heat, it will perform a skip reentry, dipping into the atmosphere, briefly bouncing back out using aerodynamic lift like a skipping stone, and then descending again for final entry. This maneuver reduces the G-forces on the crew and spreads the heat load across a longer trajectory. Even with that, Orion's heat shield will endure temperatures nearing approximately 2,760 degrees Celsius, about twice as hot as molten lava, and nearly half as hot as the surface of the sun. It's one of the most intense re-entry environments ever experienced by a crewed spacecraft. As Orion descends into the lower atmosphere, it begins deploying its parachute system in stages. First, small drogue parachutes deploy to stabilize and slow the capsule, followed by 3 massive main parachutes that gently lower it toward a targeted splashdown in the Pacific Ocean off the coast of California. There, U.S. Navy and NASA recovery teams will retrieve the capsule and crew, bringing their 10-day journey around the moon to a close. To keep Artemis II connected across its journey, NASA will rely on both the Near Space Network and the Deep Space Network. These two systems, with relay satellites and antennas spread across the globe, will coordinate to deliver communications and navigation through every phase of the mission. Handovers between networks are managed from Mission Control at Johnson Space Center in Houston, ensuring Orion stays connected as it heads to the moon. While in low Earth orbit, Orion and the SLS will use the Near Space Network. But after the translunar injection, the Deep Space Network takes over, guiding Orion through its journey around the moon. The crew will remain in near constant contact with Earth, except during a planned blackout when Orion passes behind the moon. During the flight, NASA will also test a laser communication system, periodically downlinking data to demonstrate the high-speed potential of optical links. Whether sent by radio or laser, Orion will transmit voice, imagery, video, and spacecraft health data, all of it processed, compressed, and handled by ground systems on Earth. In addition to its 4-person crew, Artemis II also carries a handful of small secondary payloads, including 4 CubeSats developed by international partners under the Artemis Accords. These compact satellites, each no larger than a shoebox, will be deployed into high Earth orbit a few hours after launch. Their missions vary, but most are focused on studying the radiation environment around Earth, testing advanced materials, and demonstrating communication and navigation technologies for future deep space exploration. Speaking of the crew, Artemis II represent a blend of experience and history-making diversity. Commander Reed Wiseman is a U.S. Navy aviator and veteran astronaut who spent over 165 days aboard the ISS in 2014 and later led NASA's astronaut office, overseeing flight operations and crew leadership. Pilot Victor Glover, a former Navy test pilot, flew on SpaceX's Crew 1 mission, logging 168 days in space. He'll handle Orion's flight controls and navigation. Mission specialist Christina Koch, who holds the record for the longest single spaceflight by a woman at approximately 328 days, will manage experiments and support spacecraft systems during the mission. Mission specialist Jeremy Hansen, a Canadian Space Agency astronaut and former fighter pilot, will make his first spaceflight, focusing on science tasks and in-flight system support. All four have undergone the rigorous Artemis training regimen. They have logged thousands of hours in the Orion simulators, practicing systems procedures, emergency drills, high-G centrifuge sessions, and underwater spacesuit practice. They've rehearsed every phase of the mission, from launch procedures to ocean recovery, using full-scale mock-ups of the SLS and capsule. Collectively, they're the most thoroughly prepared astronauts for a lunar mission since the Apollo era. On launch day, they'll suit up, travel to Launch Complex 39B, ride the elevator up the mobile launch tower, and board the Orion spacecraft atop the SLS rocket, as ground teams complete final closeouts and the countdown enters its final hours. If all goes to plan, Artemis II will launch on April 1st, sending 4 astronauts on a 10-day journey around the moon before safely returning to Earth. The next step, Artemis III, currently targeted for mid-2027, will no longer attempt a lunar landing as previously planned. Instead, under the revised mission architecture, it will focus on testing critical technologies in low Earth orbit, including docking and operational integration of Orion with one or both commercially developed lunar landers, namely SpaceX Starship Human Landing System and Blue Origin's Blue Moon. These demonstrations are essential to validate mission-critical procedures before committing astronauts to a surface mission. The first crewed lunar landing of the Artemis program is now expected to occur with Artemis IV in early 2028, targeting the Moon's south polar region, marking the transition into sustained surface missions that will continue with later Artemis flights. Altogether, Artemis isn't just about returning to the Moon, it's about building a future there, establishing a sustainable presence, enabling a lunar economy, and preparing for humanity's first steps on Mars in the 2030s. With Artemis II, we're about to witness the next giant leap in exploration, one that reaffirms our role as explorers of deep space. If you're excited to follow this journey, be sure to like, comment, share, and subscribe, because this is only the beginning.